Artificial intelligence, or AI, is a pretty loose term that just means machines that think and/or act like humans. But what does that mean? Computers traditionally think by programming. Programmers write code that spells out each step the machine is to follow and what to do in specific well-defined situations. This sort of thinking is very good for solving specific problems, for example, in making calculations. Mesh networks like Newport Wireless Mesh use mesh routing protocols that allow routers to decide the best path to get to and from the internet. But although we like to think our routers are smarter than the average router, our protocol is a traditional algorithm. It is not AI. But programmers could never program in instructions for what to do in all the possible scenarios that a machine would need to think like a person. Just thinking about a huge program like that probably gives programmers a headache. Machines need to think in a whole new way to do what humans do. This is such a complex topic that scientists have broken down AI into a number of sub-areas. They are asking, what skills do humans need in order to think? One thing that people need is to be exposed to a lot of data about the world, which happens over years of growth and development from infancy. They take in this data through senses of sight, sound, hearing, smell, taste, touch, and movement. We also need a framework for classifying and processing data. We do this through language. This framework organizes environmental inputs in ways that are shared with other humans. Humans also need to make connections among all this data and abstract from it accurate predictions about future events in order to solve problems. Problem solving in humans does not follow a linear process like a computer program, but instead seems to draw in tremendous amounts of stored data instantaneously. Subfields of AI are delving into each of these skills. In machine learning, machines are exposed to large amounts of labeled data called supervised learning, or large amounts of unlabeled data and allowed to come up with their own patterns called unsupervised learning. Either way, scientists give the machine a grade on the output. In traditional machine learning, the machine is given more help by scientists than in deep learning architectures, and correlations are simpler. The field of robotics focuses on machines taking in sensory information, navigating in and manipulating their environment. This can improve a machine's ability to learn and function in the human world. Language models focus on machines learning the linguistic framework used by humans to classify data. The machine learns to construct grammatically correct statements that sound normal to humans, but it doesn't necessarily understand the meaning of what it's saying. Deep learning is an advanced form of machine learning. Deep learning uses artificial neural networks to make complex nonlinear correlations more like humans do. These correlations enhance all aspects of machine thinking. They help the machine understand the meaning of patterns in language and other data, allow the machine to find patterns not seen by humans, and can lead to novel solutions to problems. A true thinking machine will need to combine all these skills in order to function the way a human does.